Also, this is another law in logarithms that tells us that whenever we have the log of a number to the same base, the result is 1. Okay, we'll have the log of a number to the same base, the result is 1. Also, we have that the log of 1 to any base is 0. The log of 1 to any base is 0. Okay. Also, we should remember that if I have log of, okay, let's say I have log of x to a power, let's say power n, and the base, I could do something like this here. This n could go backwards. All right. When the n goes backwards, it becomes n log x base a. Okay, this is a law. Now another law tells us that whenever I have the log of a number, okay, being added to the log of another number, okay, what I observe, I see that they have the same base. Before I apply this law here, they must have a common base. When I see they have a common base, what I do is this: I pick the log of the base, okay, then I multiply the numbers. Okay, so what I did here, I picked log to this base, then multiply the numbers. All right. Now remember, we can also move just as we can move forward. Okay, we can also move backward. Okay, so in a case where I have log of two numbers that are multiplying to a base, I could spread it to be like this addition. Okay, I could spread it to be this way. Now I also have another law that tells us that if I have log of a number, then subtracted by log of another number, sharing a common base, the result is log x divided by y base a. This is as easy as possible. It's very easy. Okay, let me show you something now. I want to give you examples on this is one, two, okay, three, four, and five. Okay, let's cite some examples here. And let's say I have, for instance, I have log 8 base 2. I have something like this now, log 8 base 2. Now I could simplify this log how 8 is same thing as saying 2 to the power of 3, okay, and it's still a base 2. Now from log 3, the n can move back, so the power here is 3. This 3 can actually move backwards, so we have 3 log 2 base 2. Now then I'll come down to the first law here. The log of a number to the same base is 1. So it means that it becomes 3 multiplied by 1 because the log of 2 to base 2 gives us 1. So the result is 3. You can see that from this question here, I've been able to apply law 1, and I've been able to apply law 3. Now we could take a simple question again, okay, that says, what if I have log of 4 to base 3 being added to of um log of 5 to base 3? Okay, let's say I have something like this. If I apply the law 4, I could say this is something as saying log 4 times 5 to base 3. Okay, so what we should have here becomes log 4 times 5 is 20. Then we have a base 3. Now in the same way, if I wanted to apply log 5, I could say when I have log 4 base 3 subtracted subtracting log 5 base 3, this is same thing as saying log 4 divided by 5 base 3. Okay, this is it. Now I'm still going to add more laws. Okay, let's stop at 5. So we can actually go deeper. Now, what if I have something like this? I have log of a, and the base a, let's say the base a is actually carrying a power. Okay, now this is when the base is carrying a power. All right, now when the base carries a power, I can decide to do this. Okay, this is the power of the base here is n. Now it could come to the back to be 1 over n log x to base a. We could do this. Okay, so let me quickly set an example here. Okay, if I have log, let's say I have log 2 to the power of x, okay, or let's say 2 to the power of 3, okay, log x, then the base is carrying the power of 3. It could be resolved. Remember, 1 over n, since n is 3 in this case, so it becomes 1 over 3 log x base 2, okay, as easy as that. Now this is 6. Now 7, what if it was the base is carrying a power that is a fraction? Let's say, for instance, I have log x, okay, a to the power of 1 over n. Okay, now what happens here? What we have at the back becomes n log x base a. Now spell out the difference. Remember, when it was just a power, not a fraction, we have a fraction at the back of the log here. Now when the power is a fraction, okay, it becomes the number n. Take note of that. Now it means that if I want to apply this, if I had log if I had log 16, let's say I had log 16, okay, I have log 16 to the power of 1 over 2, okay, I have something like this. How do I simplify this? Remember, we could apply this. um, the power at the base is a fraction, so it gives us 2 log 16 base 2, okay. Now we can still proceed from here. We can still proceed from here, right? Proceed from here. Remember, 16 is 2 raised to power 4, so this is simply as saying 2 log 16 is 2 raised to power 4, so this is 2 to the power of 4 and to the base 2. Now, remember we said the 4 can come backwards, so we have 2 times 4 log 2 base 2. Okay, now remember, log 2 base 2 is 1 from our log 1, remember, and we have 2 times 4 is 8. Okay, so that is the result of our simplification. Okay, now what if I had something like this? Let's say I had something like this. Let's say I had x log, okay, let's say I had, let's use b. Let's say we have a b log a base b multiplied by c log k base c. Okay, now when you have something like this, when you have an expression like this, okay, what you do is very simple. It's a very easy shortcut to this. Or the result is going to be a times k. That's what will be the result. I'll prove it to you. Let me show you the little proof. Okay. Now this is a simple proof to that. Now I'll say we have b log a base b multiplied by c log k base c. Okay. Now let's do this. Let's say let b log a base b, let it be equal to y. All right. So let's take the log of both sides. But remember, since what we have is a b, let's take a log to base b of both sides. All right. So if I take log of both sides to base of b, okay, take log to base of b of both sides. We're having log base b raised to power log a base b like this should be equal to log y base b. Okay. Now this is what can happen. Okay, this is what can happen. Um, this everything here from our law, the power here can come backwards. So what we have here becomes we have log a base b, okay, log b base b is equal to log y base b. Okay. Now when I have this, log b base b is actually 1. All right. So what we have left, we have log a base b is equal to log y base b. Now, this log to base and this log to b can strike out here. So we have that a is equal to y. Okay. Now in the same way, in the same way, let's let c, okay, c log k base c, let it be equal to, let's say, r. All right. So do the same thing. We take log to base c of both sides. Okay. We take log to base c of both sides. We'll be having log to base c of c raised to power log k c is equal to log to base c of this guy. Again, this guy can move backwards from our law. Okay. If he moves backwards, we have log k base c multiplied by log c base c is equal to log r base c. Now log c base c is 1. Okay. Now log c base c is 1. Now if that's the case, look what we have here. This is 1. We now have you're left with log k base c is equal to log r base c. Now this guy can go. So we have that k is equal to r. Alright. So in that case, we have said that y, everything here, is equal to a. So it means I can replace everything here, okay, as a multiplied by, we have been able to determine, we have been able to show that everything here, okay, we need to see that everything here give us k. Okay, everything here is reduced to k. So it becomes a times k. And that is the result. Okay, so a times a gives us what now? AK. So it means that if I have a question like this, anytime I see a question like this, so far, what I have here, what I have here, and what I have here, so far they are the same. What I have here and what I have here, so far they are the same. This can apply, all right? Now, let me give you a quick example here. If you have, let's say I had 2 raised to power log 2 base 3, okay, I have multiplied by 3 raised to power 3 raised to power log 4 base 3, okay. Now, once I have something like this, all right, everything here gives me 3 and everything here gives me 4. So my result should be 12. It's as easy as that. So from that proof, we'll be able to get this done, okay. We're able to get this done. So